Brian Keating, a professor of physics at UC San Diego. I got two physics questions I'm hoping you can answer or chime in on. So I study the cosmic microwave background radiation, which is the afterglow of the Big Bang, which discovered 60 years ago or so. And this radiation is thermal in origin, and we are applauding your efforts in the astronomy community to make the Starlink satellites dark for optical astronomy. But we microwave astronomers who use signals, we're trying to detect this afterglow of inflationary gravitational waves in Q-band, essentially in Q-band. And there's really no way to block out a 1,000,000 Kelvin equivalent signal that you're transmitting with Starlink. I'm wondering, is there any way we could work with you in from the South Pole or Chile, where our observatories are located, to have selective availability or some way? Because once this channel is gone, we'll never get it back. And this is, potentially precluding a view into the, inflationary origin of the cosmos. So I know it's very important to you, and we're appreciative of the astronomy efforts in optical astronomy, but microwave is a totally different ballgame.
Sure. I do think long-term, the right place for telescopes or really any receiver is in orbit, or basically space, so you don't have experience from Earth. And as Starship starts launching, we can have some pretty big telescopes or photon receivers.
We have 10-meter diameter telescopes, so pretty hard to put, and they don't really unfold the way that Webb would. But I mean, I think it would be something that selective availability. I'm basically blanking it over the South Pole. We only have 2 locations on Earth where we would need to have it unobstructed.
Okay. Would you say basically just stop transmitting just over these?
Yeah, the 2 observatories. Yeah, in the Atacama Desert in Chile at 17,000 feet, and the South Pole, Antarctica, which is place we'd love to take you. By the way, Simons Observatory, Jim Simons funded it, and the NASA Science Foundation funds the South Pole Observatory called BICEP. So if you have any resources you could put me in touch with, it would be really appreciated.
We have a technical update every week. So I'll ask about any obscuration and microwave spectrum in Atacama and Antarctica. So we don't wish to in any way impede the progress of science.
That would be awesome. Thank you, Elon. I have one more question just related to physics and AI and related to Catherine's book, which brought us all here together tonight. So Catherine, congratulations, Mazel Tov on the book. So the book's called No Apologies. One of the things I hate most about ChatGPT, woke GPT, is, you'll ask it some question. I'll say, what did Brian Keating write? And I'll say, losing the Nobel Prize, correct. Into the Impossible, correct. And then I'll say, A Brief History of Time. No, that's not correct. And I'll say, no, that's not right. I didn't write. That's Stephen Hawking. And they'll say, I apologize. I hate that. I want the Catherine Brodsky no apologies. But it made me think about a true Turing test. And I want to get your opinion on. I've asked Nick Bostrom and David Chalmers and your greatest ideas and thinkers, Peter Diamandis, our mutual friend. I said, do you know what Einstein called his happiest thought, Elon, that gave him shivers and titillated him? Do you know what he said that was? He said, it's PG, don't worry. He said, he said it was that an observer in free fall would experience no gravitational force. And it made me think, because to what extent could a computer or some silicon or even quantum computer, could it even have either a happiest thought or B, experience the sensation, a visceral sensation of free fall? So I'm wondering if we could propose another, kind of Turing test, a different definition of AGI, which would be actually coming up with new laws of physics or new complete paradigms of physics, rather than just, physics is the base layer of reality. I mean, you always quote that, right? So to what extent could we redefine AI as when it becomes generally intelligent, when it can experience happy thoughts, free fall, and other things like that? So curious about your thoughts.
Well, I think you can certainly have AI would not realize it's in a simulation, which may be the case for us right now. And that would have a true physics engine fall in a way that a human would fall, and thus experience sensations in the same way. I do think there are the simulation hypothesis does explain some elements of quantum mechanics, such as, only collapsing the probability distribution when you look at something. Like, why would something be only true when you look at it? Well, if it's rendering in real time, then that's actually how a video game works. Like if you're in a video, like let's say you're in World of Warcraft or something, and you walk through a forest and there's a rat, and a rat appears. But before that, was there a rat or not a rat? There was only a probability of a rat, and the rat only became real when you looked in that direction. That collapsed the probability space, and the rat appeared. So I think conversion theory actually explains a lot of things that seem quite mysterious, the Schrodinger's cat situation.
But it requires infinite compute, right? Because they could always say who simulates the simulator, infinite regress, right?
It does beg the question of where is the simulator running?
Yeah.
And it may be that you have a whole series of nested simulations. But at some point, there is the undead thing.
But ultimately, the physical reality, I mean, all these things are going to be running on a rocky planet somewhere, right? That doesn't have infinite copper. It doesn't have infinite mineral density to retrieve. So, I mean, there are planetary limits to growth, as, the Club of Rome would call it. Don't those provide? I mean, you can't imagine, changing the physical reality of an Earth-like planet. You can't imagine these simulations running on something very different from an Earth-like planet. It's not going to run on a Boltzmann brain. So at some level, it needs physical reality. And so, again, you can't break the laws of physics. So how does it get around the planetary resource problem? You can't make an infinite number of paper clips on a finite planet.
The universe may seem infinite to us, but frankly, if I was creating a simulation of this reality, I would put the stars far enough away that we do not have to simulate the details of the planets. And in fact, that is the situation. So you really just have to simulate with high fidelity what is observed on our planet. A much easier task than trying to simulate local reality. And I was joking that, when the James Webb telescope went up, that maybe the reason for the delays was that the simulators needed to bring more computers online, because now that we could see further, they needed to improve the fidelity of their simulation. So like their equivalent of Amazon Web Services or something. If I wasn't at least pretty good at physics, then the rockets would explode and the cars wouldn't work. Because physics is a very harsh judge. I mean, I like to say that, physics is the law and everything else is recommendation, meaning that, you can't break physics, but plenty of people can break the law. And if you're breaking physics, you're either wrong or you need a Nobel Prize, but most likely you're wrong.
Elon, can I ask you a question as a father of half as many kids as you have?
Sure.
So I've heard it said, you want to die on Mars. And our mutual friend, Lord Martin Rees, said, I just hope it's not on impact. And I agree with that. Being a father, you've got that cute kid probably right next to you. I mean,
he's on my shoulders right now.
Yeah. I mean, but you have other kids too. And to say goodbye to a child is, I don't have to tell you that. It's the most painful thing you could ever imagine. But wouldn't you have to? I mean, wouldn't that be kind of the ultimate going away on a business trip if you were to do that? I don't know. I find it hard to go away on a trip, but I know you take your kids with you. I got one of my girls right here with me right now, and she doesn't want to go to bed. I mean, what would you do? I mean, could you really say goodbye to some of your kids or some of the people you love, maybe your mom, and never see her again?
Well, I don't want to say goodbye.
I think we don't have to worry about that for a few more years.
Okay.
I think so too. Plus, maybe they'll want to come on the trip, right? You don't know.
Yeah.
And maybe it'd be quicker, so you can come back if you want.
Yes, you fear a lot of things in your life, but most don't happen.
That's very true.
Very true.
Thank you, Elon.